Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the ninth part of the series of physics June November 2020 paper solutions. Okay, so and also I would like to request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so we are solving part C questions of CSIR net physics June November 2020 paper. Okay, so I'll start now of a particle. Okay, moving in one dimension, moving in one dimension, moving in one dimension is given by is given by is given by Vx equal to V naught sine uh, pi x upon x naught, where V naught and x naught are positive constants of appropriate dimension appropriate appropriate dimension. Okay, appropriate dimensions if if particle is initially if particle is initially at x equal to at x upon x naught equal to epsilon. Okay, where mod of epsilon uh, is less equal to 1. Okay, very small, then in the long time it number A executes an oscillatory an oscillatory an oscillatory an oscillatory motion around x equal to 0. Option B is tends towards x equal to 0, tends towards x equal to 0. Option C is tends towards tends, very good question guys, okay, tends towards x equal to x naught, x equal to x naught, and option D is executes 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 an oscillatory motion, and oscillatory oscillatory motion around x equal to x naught, around x equal to x naught, around x equal to x naught. Okay, so this is the question guys, very good question. Okay, so I would like to read it again. So the velocity Vx of a particle, okay, moving in one dimension. Okay, so particle is moving in one dimension whose velocity is Vx, okay, is given by, that velocity is given by V naught sine pi x upon x naught, okay, where V naught and x naught are positive constants, okay, so they are constants of appropriate dimensions if particle is initially at x upon x naught equal to epsilon, okay, at initially the value of x upon x naught equal to epsilon, right, where epsilon, mod of epsilon is very less than 1, okay, then in long time t, it executes an oscillatory motion around x equal to 0, or B tends towards x equal to 0, or tends towards x equal to x naught, or option D is executes an oscillatory motion around x equal to x naught. Okay, so this is the question guys. Well, so now I'll explain this. Okay, so first we have given, that is, we have been given, we'll write whatever we have been given. Okay, we have been given Vx. Okay, we have been given Vx equal to this is V naught sine pi x upon x naught, okay, so this is what we have been given. Now we'll find Ax. This is velocity. Now we are finding, that is Ax, that means the acceleration. Okay, so we'll differentiate this, right, d upon dt, V naught sine, there is a reason of doing that. Okay, I'll explain later. So that is pi x upon x naught, okay, this one. Now we'll differentiate it. So this is going to be V naught, the differentiation of sine is cos pi x upon x naught, and we'll differentiate this, right, we have because it's a differentiation, we have this pi x upon x naught equal to t, we can suppose. So this is going to be this differentiation is going to be pi upon x naught dx upon dt, right, that is Ax. Okay, now it is going to be V naught cos pi x upon x naught, okay, and this we can take in this side. Okay, this is constant, so V pi upon x naught, and dx upon dt is Vx, right, that is the velocity, since Vx equal to dx upon dt, right, so we can write the value of Vx, right, dx upon dt, that is V naught sine pi x upon x naught, okay, this one. Now we can take this this is going to be Ax equal to V naught square pi upon x naught, and this is sine A sine B, right, sine A cos B, So we what we can do is we can multiply by 2 sine pi x upon x naught and cos pi x upon x naught, and we can divide by 2, right? This one we can do it, right? We have multiplied by 2 and divided by 2. So this is 2 sine a cos b, right? 2 sine a cos b means sine 2a, right? So this then ax is going to be ax is going to be this one v naught square pi, this is v naught square pi upon x naught this is sine, this is 2, okay? Sine 2a means 2 pi x upon x naught, 2 pi x upon x naught, okay? Very simple calculation, this one. Now this this which is given, right? X upon x naught is given, that is epsilon, and that is very less, okay? That is less than 1, right? So means this the sine theta value is going to be very small, and for very small value of theta, we can write sine theta is almost equal to theta, right? So we can write ax, this is for small value, for small value of theta, okay? Small value of theta, this we know, okay? So ax is going to be that is v naught pi upon 2x naught into 2 pi x upon x naught, okay? Well, so this is going to be ax is going to be equal to v naught square, this is v naught square, guys, okay? V naught square, 2 will get cancelled, okay? V naught square, this is v naught square pi square upon x naught square x, right? So ax we know, right? Ax is dx to d2x upon dt square, right? That is the acceleration, d2x upon dt square, right? This we know. So we'll put the value. So this is going to be d2x upon dt square. We're writing this in differential form, okay? Equal to we can write this kx square, where value of k is this one, v naught pi upon x naught whole square, okay? V naught pi upon x naught whole square, that value is going to be v naught square pi square x naught square, right? We can write, and this is x, guys, just x, okay? This is x, this is x. Well, now what we are going to do is we'll take this left hand side, so this is going to be d2x upon dt square minus k. This is k, right? So this is going to be k square, right? Value of k is this. So k square x equal to 0. So from here we can get value of, so I have already explained in quantum mechanics, right, how to solve this differential equation, and even I have explained this in mathematical physics. So I have taught differential equation in detail, so you can check it. So from here the value of x is going to be it's a homogeneous equation of second order, right? So we know that auxiliary equation is going to be m square minus k square equal to 0. So m square equal to k square, that means value of m equal to plus minus k, right? And so the solution is going to be solution for this is going to be a e to the power kt plus b e to the power minus kt, right? Value of k is this, okay? So this is the value. Well, So I have explained in quantum mechanics class. I have told you, if I've told you here, if psi equal to e to the power iota kx plus a, okay, and b e to the power minus iota kx. If this is the case, then this is oscillatory motion. Okay, this is the oscillatory motion of particle. If psi is just a e to the power minus iota e to the power kx plus b e to the power minus kx, this is because there is no iota term in e to the power, right? It means it is non-oscillatory motion, guys. Okay, this is a non-oscillatory motion, means these two options are already incorrect. Okay, so this executes oscillatory motion executes, so b and d are not correct, guys. Okay, so the now the answer will be option b or option c. A and d are not correct, guys. Okay, so we can exclude those things. Okay, if okay, so you need to know that if e to the power iota is there, okay, so e to the power iota k, if there would be e to the power iota kt plus b e to the power minus iota kt, if there would be e to the power iota kt, then that would be oscillatory motion. You need to note down. And if there is just there is no iota term in e to the power, it means that is non-oscillatory motion. Okay, so this is oscillatory motion. Okay, and this is no iota term, right? This is non-oscillatory motion. You need to note down and memorize it, guys. Very important. Okay, this one. Okay, so now what we can do is t is like in question it is given, right? We need to find that then in long run. Okay, in long run, in long time t, so we can suppose as long time means as t tends to infinity. Okay, the value of x is going to be a e to the power kt, right? Because b will be 0 at t tends to 0, b is going to be 0. Okay, at t tends to 0, b is going implies b is going to be 0 because e to the power okay, yeah, at t tends to 0, if you put t tends to 0 in this equation, right, then x is going to be, then value of at t tends to x is going to be a e to the power uh, this one, right? T tends to 0 means this. Okay, at t tends to 0, this is going to be e to the power kt, right? Since b equal to 0 for t tends to infinity, at t tends to infinity, b is going to be 0. Okay, value of b is going to be 0. Okay, this I have also explained in my quantum mechanics class. So now x is, now we have the solution for this equation, that is x is, value of x is value of x is going to be this one, a e to the power kt. Okay, now if k is small, okay, k is small, okay, and t is large, which is given, and t is large, t is large, right, tends to infinity. Okay, t is large, in that case large, this implies, okay, this implies value of x, we can, this implies value of x is some fixed quantity. Okay, value of x is some fixed quantity, some fixed quantity, fixed How? This is very large, okay? K is small, very small, and this is very large, where it tends to infinity, right? So this, if it is large, it is small. Their multiplication is going to give finite value, right? Finite value means value of x is going to be some fixed quantity, right? So value of x is some fixed quantity. So if k is small and we know t k is small and t is large, right? T is large given in the question in long time, right? Tends to infinity. So in that case, the value of in that case, if you multiply k and t, that is going to give finite value, okay? And then the value of x is going to be finite value and some fixed value, right? So value, it doesn't, that implies value of x is some fixed quantity, okay? So this implies option C is the answer, guys, because so at long time t, this is what given, okay? As long time t, yeah, then in the long time t, long time, it means the particle tends towards x equal to x naught, okay? X equal to x naught means a value is going to be fixed constant, okay? A fixed value, that is constant value, okay? So option C is the correct option, guys. I hope, guys, you have understood it. Now next question, guys, okay? Next question is this is also a good question, guys, okay? And question is this question is from quantum mechanics, okay? The energy density, question 2, the energy density, the energy density, the energy density I, energy density I of a black body radiation, of a black body radiation. It's a good question, guys. The energy density I of a black body radiation, at temperature T, at temperature T is given by the energy density I of a black body radiation, okay, at temperature T is given by Planck's distribution function, given by the Planck Planck's distribution function, Planck's distribution function, Planck's distribution function I, which is function of nu t. Nu is frequency and t is temperature, okay? Which is function of nu t, is given, that is equal to 8 pi nu square upon c cube, 8 pi nu square upon c cube into h nu over t to the power h nu upon k. T, k is Boltzmann constant, right? Okay, minus 1, okay? Where nu is the frequency, nu is the frequency, okay? The function I, that is energy density, which is function of nu and t for two different temperature, two different temperatures, for two different temperatures, for two different temperatures T1 and T2 are shown below. Are shown below. Okay. Are shown below. Okay, I'll make a diagram for that. Okay, and if two cups, if the two cups, if the two cups, if the two cups coincide when I, which is function of nu t, into nu to the power a is plotted is plotted is plotted is plotted against nu to the power b upon t. Okay, then the values of a and b, then the values of the values of the values of a and b a and b are respectively options are 2 and 1. Option B is minus 2 and 2. Option C is 3 and minus 1, and option D is minus 3 and 1. Okay, so these are the option, and I'll make a diagram, then it will be easier for you to understand the question. Okay, so these are two graphs is given. Okay, this is the graph. Okay, this is at T2 temperature and this is at T1 temperature. Okay, and this is nu versus I, energy density versus frequency. Okay, this is the one. Okay, so I'll read the question for you and then I'll proceed further. Okay, okay, so the question is, the energy density I of a black body radiation at temperature T is given by Planck's distribution function. Okay, I Vt, which is 8 pi mu square upon c cube into h nu upon e to the power h nu by kt minus 1, where nu is the frequency, and the function I, which is function I means the energy density, which is function of nu and t for two different temperatures T1 and T2 are shown below. Means this is the graph which is given. Okay, so this is the graph for I, okay, which is function of nu and t. These are the two graphs at different temperatures. This is at temperature T1 and this is at temperature T2. Okay, now if the two curves coincide, okay, if the two curves coincide, okay, if the two curves coincide when, okay, these two curves will coincide. Okay, these curve will coincide if we plot. Okay, that's what it is asking. When we plot, when uh, I which is function of Vt, right, I which is function of nu t, I into nu to the power a, when I into nu to the power a is plotted against nu to the power b, nu to the power b upon t, okay, then the value of a and b are, okay. If you plot the graph between I and this I into nu to the power a versus nu to the power b upon t, okay, then these two uh, cups will coincide, okay, then the value of a and b we need to find out, okay. Very good question, guys. These are part C questions and these are very good questions, guys, and for these questions you need practice, guys, okay. You need to solve it and revise it, then you would be able to solve these type of questions, okay. Well, so I'm going to so now I'll solve it. So we have been given, that is I, we have been given I equal to uh, that is 8 pi nu 8 pi nu cube upon c cube into h upon e to the power h nu upon kt. K is Boltzmann constant, right? Okay, this is what given, okay. Okay, so this is what given. So now we can write for this is for the these curves, guys, okay. Now we need to plot graph between this between I into nu to the power a versus nu to the power b upon t, okay. And if you plot the graph between these plots are going to be coincided, okay. And and that and we need to find for what value of a and b these are going to be coincide, okay. Well, let now what we can do, let so now this is the I, right? So we let y equal to, we have this value, okay, y equal to I v to the nu to the power, right? Let I equal to I nu to the power, okay. Let's suppose we have put this value I equal to nu to the power, okay. So we can write like this. Right? This is good, I into nu to the power a. I is the that energy density, right? So now we'll put the value. So this is going to be I value is given, right? This is 8 pi nu cube upon c cube h upon e to the power h nu upon kt minus 1, okay. Now what we can do is we can, so this is going to, and nu is also there, okay, nu to the power a is also there. So this is going to be, now we can write like I, y is going to be nu and nu will get added, right? So this is going to be 8 pi nu to the power 3 plus a, right, h upon e to the power h nu e to the power h nu upon kt into, what we can do is we can multiply by nu to the power b and divided by nu to the power b, we can do it, right, into nu to the power b into nu to the power minus b, we can write it, multiplied by divided, right. So we can write this, so this is not going to affect this expression, right, minus 1, we can do it, okay. So then y is going to be I'll write in next page, there is no space, enough space, okay. So I is going to be 8 pi 8 pi h 8 pi h h is there, right? So we can write 8 pi h upon c cube nu to the power 3 plus a into 1 upon, this is going to be e to the power this one, this we can write nu to the power b upon nu to the power b, or we can write this one, this is going to be e to the power h nu to the power, this is going to be nu to the power minus b plus 1, we can write minus b plus 1, and into, we can write this one, okay, b, and we can write nu upon nu to the power b upon t minus 1, right, because it is s nu upon kt, right? So h nu upon k, this is this one here, right? E to the power nu, sorry, nu to the power b means nu to the power b, and nu to the power nu is nu to the power nu to the power nu to the power minus b, and nu is nu to the power, base are same, so this powers will get added, right? Nu to the power minus b plus 1, and this is nu to the power, this is kt, right? So this is nu to the power b upon t, nu to the power b upon t, and this value we say let uh, nu to the power b upon t is x. Let's say this value is x, okay, this value is x. Now we'll put the value, so this is going to be, I is going to be, this is constant, guys, so we can write alpha nu to the power 3 plus a upon e to the power, this is h nu, so this is going to be h nu, this h upon k is constant, right? So we can write beta instead of this, okay, beta, that is constant, and then nu to the power minus b plus 1 upon this value is x, right? This value is x, x minus 1, right? So this is the value. Now it is this, then y, this is y, guys, okay, this is y, this is y, this value is y, okay. So now you can see this is the y is equal to alpha nu to the power this one, right? So alpha, and this this is this, so right, this is the one, we can write like this, beta, and now this value is going to be for a equal to minus 3, if we place 3 minus 3 in place of a, okay, in place of a, if we place minus 3, this is going to be nu to the power 0, that value is 1, right? And if you write b equal to plus 1, if you write b equal to 1 or plus 1, b equal to 1, then nu to the power b minus nu to the power minus 1 plus 1, nu to the power 0, this value is going to be 0, then the value of y is going to be for a equal to minus 3, b equal to 1, the value of y is going to be alpha, okay, alpha into 1 upon e to the power beta x minus 1, okay, where alpha beta are constant. So here you can see the value for value of a equal to minus 3 and b equal to minus 1, we are getting the constant value, right? Alpha into 1 upon e to the power beta x minus 1, right? We are getting this value, beta x minus 1, okay, constant value. So it means for value of a equal to minus 3 and b equal to minus 1, these two graph will coincide, these two graph will coincide because this value is constant, right? Okay, well guys, I hope you have understood it, guys. It's a good question, guys. I would request you to practice it, and this will help you guys, okay. So well, so which option is matching, guys? Let me check. So a equal to, this is answer, guys, okay, a equal to minus 3, b equal to 1, okay, let me check. A equal to minus 3, b equal to 1, so option D is matching, guys. Option D is matching. Option D is matching. Okay. Next question. It's a good question, guys. Next question. Next question is question number 3rd. This is for an ideal gas. For an ideal gas. For an ideal gas consisting. For an ideal gas consisting of undistinguishable particle and undistinguishable particles in a volume V, the probability of finding exactly two particles in a volume del V less equal to V, very del V, okay. In volume del V we need to find out which is very less than V, okay. In the limit n and V tends to infinity, okay. Where V is very large, okay, tends to infinity, is options are, very good question, options are 2n delta V upon n, my apologies, it's 2n delta V upon V. Option B is n delta V upon V whole square. Option C is n delta V upon 2V square whole square, n delta V upon 2V and delta V whole square upon 2V square e to the power minus n delta V upon V, okay. And option D is delta V upon V whole square e to the power minus n delta V upon V, okay. So this is the question, guys, very good question. I would like to read it for you first, okay. So this is for an ideal gas consisting of n distinguishable particle, okay. So for an ideal gas consisting of n distinguishable particles, okay. So then there are n distinguishable particles in ideal gas, okay. Particles in volume V, or volume of that ideal gas is V, okay. The probability of finding exactly two particles, okay. You need to find out the probability of finding exactly two particles in volume delta V. So in volume delta V you need to find out probability of finding two particles, okay, where V is very less than delta V. My apologies, where delta V is very less than delta V. Delta V is very less than V, okay. In the limit n where V tends to infinity, where V is very high compared to delta V, right. So now we need to find probability. So here we can see I'm going to solve it. Okay, here we can see v tends to infinity, delta v is very less, right, and v is very very v is very high, or very large in compared to delta v, right? So in that case, what we are going to do, in that case we are going to use Poisson equation. Okay, my apology, it's Poisson distribution. Okay, Poisson distribution, Poisson distribution. Okay, so that is, so we'll use Poisson distribution. Okay, we can use Poisson distribution, use Poisson's distribution. Okay, we call it Poisson's distribution, guys, but that is not correct. It's a French name, and pronunciation of it is Poisson. Okay, Poisson distribution. Okay, it's a French name, so we can use Poisson distribution. Okay, x equal to, we can write fx or px will write. Okay, px equal to its probability, that is, we know mu to the power x into e to the power minus x factorial, right? This is what we know by Poisson distribution. Okay, this one, this we know because v is very large compared to the delta v, right? This is the Poisson distribution. Okay, so r is this one, right? X factorial, right? So we'll find mu is the mean, right? Mu is going to be, or we write probability, right? PR equal to this also we can write PR equal to m to the power r e to the power minus m upon m factorial, the same thing. Okay, this is same thing. Instead of r we have taken this x. Okay, so mu, value of mu is, we know value of mu is here, the value of mu here you can see this volume is very small, very small compared to this. Okay, as compared to this tends to infinity, very large. Okay, so mu is going to be, that mean is going to be, that is, n is the number of distinguishable particle, right? N into del v upon v. This is very important, you need to know. The value of mean is n delta v upon v, n delta v upon v, right? Now we can easily find out. Now probability of getting exactly two particles in volume delta v, that is going to be, we'll use Poisson bracket, right? Poisson distribution, and that is going to be Poisson distribution. Okay, and that is going to be this one. Mu is this, right? Mu n delta v upon v to the power, where x equal to 2. Okay, x equal to 2, so to the power 2, getting two particle. Okay, that r is number of particle or x is number of particle, so getting two particle is that mu n delta v upon v to the delta v upon v to the to v whole square. Okay, into e to the power minus mu, right? That is n delta v upon v, and delta v upon v upon 2 factorial, right? 2 factorial, x is number of particle, right? 2 factorial. This is the one. This is very important. Okay, guys, mu is n delta v upon v. Okay, for this case. So this is going to be, now we'll solve it. So this is 2 factorial is 2, right? So this is going to be n delta v whole square upon 2v square. We can write the value of 2 factorial is 2, right? 2 into 1, that is 2. 2, and this is going to be e to the power minus n delta v upon n delta v upon n, e to the power minus n delta v upon n. Okay, so this is the answer. Very nice, very good question, guys. What so this is the question which is given. We just have to use Poisson distribution, okay, and we have used Poisson distribution and got the answer. Okay, so this is the answer. So which option is matching, guys? Let me check. Option C is matching, guys. So option C is this. Okay, n delta v n delta v whole square upon 2v square and delta v whole square upon 2v square into e to the power n. This is also a good question, guys, and this question is from statistical mechanics. Okay, so the Hamiltonian of a system Hamiltonian of a system of 3 spins. Hamiltonians of a system of 3 spins. Okay, there are 3 to J into S1 S2 plus S2 S1 S2 S3. Okay, S1 S2 plus S2 S3, where SI value is plus minus 1. Okay, for plus minus 1 for I equal to 1, 2, 3. Okay, its canonical partition function. Very simple question. So little bit there is a calculation on it. Okay, so its canonical its canonical canonical partition function at temperature T is, okay. Options are given. Option A, 2 into 2 sine hyperbolic j upon kt whole square. Option B is 2 into 2 cos hyperbolic j upon kt whole square. Option C is 2 into 2 cos hyperbolic j upon kt. Okay, and option D is 2 into 2 cos hyperbolic j upon kt whole cube. Okay, so this is the question, guys. Very simple question. Hamiltonian is given. Okay, the Hamiltonian of a system of 3 spins is given. Okay, where SI value is plus minus 1 for I equal to 1, 2, 3. Its canonical partition function at temperature T is, you need to find out its canonical its partition function you need to find out. Okay, very simple question. So I'm going to solve it. This is the question from Ising model, guys. Okay, so I'll make a chart first. So values of, write S1, S2, S3, and this is Hamiltonian. Okay, that is S1, this one, J into S1 plus S2, S2 plus S3. Okay. j into s1 s2 plus s2 s3. Okay, j equal to h equal to j into s1 s2 plus s2 s3, right? This one. So this is going to be now s1 values s, right? So s1 si values plus minus 1. Okay, that s1 is s1 value may be s1 value may be 1 or minus 1, s2 value may be 1 or minus 1, s3 value 1 or minus 1, right? So we'll write it. So now first we'll take 1 1 1. For 1 1 1, this is going to be, we'll put the value, right? So value of h is going to be this j 1 1 1 1 1. This is 2j, right? Similarly for the again 1 1 minus 1, so this value is going to be 0. Again this next is 1 minus 1 1. Okay, this value is 0. Why? J s1 1 1, this one 1 1 minus 1 and minus 1, this 2 and 1, right? 2 and 1, this one, this is the 0. Next, no, my apologies. So there is, yeah, that's correct, minus 1, right? Next is third, 1 minus 1 minus 1. Okay, okay, so there's a procedure for writing it, guys. That's I would like to teach you. Okay, this value we can easily find out. So first we have taken 1 1 1. Okay, then 1 minus 1, this, right? Then we'll take this one 1, this minus we have taken, now this minus 1 again, now this minus 1 1. Now we'll take minus 1 minus 1 minus 1. Okay, now we'll take minus 1 minus 1 plus 1, right? Then minus 1 plus 1 minus 1. Then 1 minus 1 minus 1. 1 2 3 4 5 6 7 8. Okay, and also by formula we can get, it would be 8. This one, number of states will be 2 to the power 3. Okay, because there are 3 spins, right? So 2 to the power 3 means 8. Now we can put the value. So this is 1 minus 1 1, 1 minus 1 1. So this is 0 value. Third is 0. Now fourth is going to be, this is 0. Now fourth is minus 1 1 1. Okay, minus 1 1 1, this value is 0. Okay, now minus 1 minus 1, 3 times minus 1, this value is 0. You can calculate it, guys, very simple, right? 2j. And next minus 1 minus 1 1, minus 1 1, this is 0. This is 0. Okay, now 1 minus 1 1 minus 1. Okay, minus 1 1 minus 1, this is minus 2j, minus 2j. And this 1 minus 1 minus 1, this is 1 minus, this is minus 2j. Okay, these are the value, guys, very simple. Like for one, I can show you this. H equal to is going to be, we'll put j into s1 is s1 into s2 1 1. So very simple, and these are the values. Okay, so these are the value of h, we have got it. Okay, h means energy. So also there is a procedure, number of state will be 8. Okay, 1 2 3 4 5 6 7 8, right? So we can also get that number of state by formula, like number of states equal to 2 to the power 3, because there are 3 spin, right? 2 to the power 3 means 8, because there are, s can take value plus minus 1, 2 values, and there are 3 spins, right? So 2 to the power 3, that is 8. Okay, so now very simple partition function will find. So partition function is that we know, right? Partition function is z equal to sigma I gi e to the power minus beta I, beta ei, right? Beta ei is energy, that is Hamiltonian, right? This energy, that is energy E, right? Now you can see 2j are two values, okay, means degeneracy is 2 for 2j, and for 0 degeneracy is 4, and for minus 2j degeneracy is 2, right? So this is going to be this one 2j for 2 into e to the power 2 into gi is 2, right? 2 into e to the power minus beta 2 beta e, right? And plus 2 beta e will be, so it's a minus 2 beta because this value is, this is 2j, right? 2j in place of e we'll write 2j, so this is going to be 2 beta j e to the power, so this value is going to be minus 2 beta j, right? Instead of e we have written that is 2 beta j, right? So this will be 2 beta j, yeah, instead of e it's 2j plus 2 for this, again it's a minus 2j, right? So degeneracy is 2, so it is g 2 into e to the power minus 2j minus minus plus, right? Minus minus plus, so this is going to be 2 beta j, okay, plus now this one, the degeneracy is 4 e to the power 0, right? So this is going to be 4 into e to the power minus beta into 0, e is 0, right? So this is 0, e to the power 0, right? So this value is going to be 2, this value is going to be 2 e to the power minus 2 beta j plus 2 e to the power 2 beta j plus 4, right? This is the partition function. Now we need to select one option, right? So we'll convert that answer into this form, okay? So very simple, we'll proceed further. So z is going to be z is going to be z is going to be we can take 2 common, so this is e to the power, we can write beta 2j or 2 beta j plus e to the power minus 2 beta j, right? Minus 2 beta j plus 4, we can write like this, right? And now what we are going to do is we have taken 2 common, right? And this value we know, right? So this is going to be z equal to e to the power 2 is common, right? Is outside, 2 into e to the power beta j plus e to the power minus beta j whole square minus 2 plus 4, we can write like this, okay? Why? This is e to the power 2 beta j and plus e to the power minus 2 beta j, right? So this is going to be like this, that this is we can write e to the power, this we can write e to the power this one, e to the power of beta j plus e to the power minus beta j whole square plus 1, because if you open it, so this is going to be e to the power 2 beta j plus e to the power minus 2 beta j and plus 2, right? And we have so we have subtracted minus 2, right? And that plus 2 and minus 2 will get cancelled, right? Then this value is going to be the same, this one, okay, if you open it. This step is important, guys. I hope you have understood. Very simple. If you open it, this is going to be, I'll show you, this is going to be e to the power, 2 beta j plus e to the power minus 2 beta j plus 2 into e to the power beta j, e to the power minus e to the power minus beta j, e to the power, this value is going to be 2, right? Now what I have done is this minus 2, right? This will get cancelled and this will give the same value. So instead of this, I have put this value, right? There is a reason for this. So now this is going to be very simple step. So this is going to be z value is going to be 2 into this one, e to the power beta j plus e to the power minus beta j whole square, minus 2 will multiply this, okay? This is going to be 4 plus 4, right? This will get cancelled. So z is going to be this. Now what we can do is we can multiply by 2 and divide by 2. So it is going to be e to the power beta j plus e to the power minus beta j by 2 whole square, right? And this value we know, so right, this is going to be z equal to 2 outside, and this is going to be 2 into this e to the power theta plus e to the power minus theta by 2 is cos hyperbolic theta, right? So cos beta j, cos beta j, cos hyperbolic beta j, right? This is 2 into cos hyperbolic beta j. And here we know, since beta equal to 1 upon kt, right? So this value is going to be 2 into, this is whole square, right? 2 into 2 cos hyperbolic j upon kt whole square. 2 into 2 cos hyperbolic j upon kt whole square, right? So which option is matching, guys? Let me check. Option B is matching, 2 into 2 cos hyperbolic j upon kt whole square, right? So option B is the correct option, guys. Option B is the correct option. Okay, guys, so I'm going to stop here, right? And also, guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack exams related to physical science. Okay, guys, thank you so much. Bye now.